Now let's talk about how the data warehousing has evolved with the cloud. Traditional data warehouses were designed before the cloud era and are generally based on a small fixed cluster of machines. These systems are powerful, but they lack the flexibility and elasticity that cloud based solutions can offer. In traditional data warehousing, you often have a complex setup with a separate pipeline for extract, transform, load, ETL process. ETL requires specific data to be extracted, processed, and then loaded into the warehouse, which can be time consuming and resource intensive. One of the main challenges with these systems is that they assume the data coming in is structured and is from a predictable internal source like a transactional database or a ERP system or a CRM tool and so on. However, data in today's landscape is far more diverse. With the rise of internet, mobile devices, social media, IoT, businesses are now dealing with semi-structured data or even unstructured data formats like JSON, XML, logs, or some sort of clickstream data, and so on. These types of data don't fit well within the rigid schemas of traditional data warehouses, creating a friction for our organizations trying to analyze real-time diverse data sets. In contrast, Snowflake was built to handle this type of modern variable data. It allows organizations to store structured and semi-structured data in a way that maintains performance with the flexibility. By natively supporting semi-structured data, Snowflake makes it easier to load, store, and analyze this information without needing a complex transformation upfront. This capability allows Snowflake to accommodate the fast moving and constantly evolving nature of modern data. So, to summarize, the cloud has enabled a shift in how data warehousing is approached. Snowflake embraces these new data realities, adapting its architecture to allow seamless handling of all types of data while leveraging the flexibility and scalability of cloud. This makes it an ideal choice for our organizations that need to process a wide variety of data without the burden of a traditional ETL and rigid infrastructure. Now, let's talk about the topic of big data. By late 2000s, new platforms specifically designed for massive data processing emerged, such as Hive, Spark, BigQuery, and so on. All these were super famous. These systems were created to manage large volumes of data across the distributed clusters and to handle both batch and stream processing. With SQL-like interfaces, they became popular for large-scale data processing tasks. However, despite their popularity, these big platforms came with certain trade-offs. First, they lack the efficiency and feature set of a traditional data warehousing technology. Many big data solutions excel at processing high volumes of data, but they often fall short in areas like transactions, backup, security, and so on. Snowflake's approach aimed to combine the scalability of these big data platforms with the advanced feature set of traditional data warehouses. This meant keeping the rich functionality of SQL-based data warehousing while being able to handle vast, diverse data sets. Another challenge with big data platforms is the amount of engineering effort required to deploy and maintain them. They often need custom configurations, large teams to manage the infrastructure, and extensive tuning to achieve optimal performance. In contrast, Snowflake's vision was to deliver a data warehouse as a service, completely managed and free from the complexities of infrastructure and tuning. By creating a platform that leverages the cloud but offers a fully fledged, fully featured SQL compatible experience, Snowflake bridges the gap between the traditional data warehousing and the big data processing, giving users the best of both worlds. So, what exactly is Snowflake's vision for a cloud data warehouse? Snowflake's founders set out to create a platform that would simplify data management by offering a data warehouse as a service. This meant building a solution where users could store, process, and analyze data without needing to worry about the infrastructure, hardware, or tuning parameters. The focus was entirely on user experience, ensuring that anyone from business analysts to data scientists could easily access and analyze data. Snowflake's vision revolves around few core principles. First, they wanted a no knobs experience, meaning there are no tuning parameters or complicated settings that user need to adjust. Traditional databases often have many parameters that require fine-tuning for optimal performance, but Snowflake automates these processes, allowing users to focus on their data and not on the database administration. Another essential part of this vision is what Snowflake calls multidimensional elasticity. This concept allows Snowflake to scale compute and storage resources independently on demand. For example, if a user needs more compute power temporarily, they can increase the compute resources without also having to pay for the additional storage. This flexibility aligns with the cloud principles and ensures that users only pay for what they need when they need it. Snowflake's vision also includes native support for all types of business data, from traditional structured data to semi-structured formats like JSON, XML, Avro, and so on. This comprehensive data support means that companies can consolidate all their data, both structured and semi-structured, in a single platform. By offering a data warehousing as service with no infrastructure to manage, Snowflake provides a simplified and streamlined solution that removes the typical friction and overhead seen in traditional data warehousing setups.